Hi guys, let's look at some absolute value graphs. So all we're going to be doing right now is identifying some key attributes to our absolute value graphs. Next time we will be looking at what they're really going to be doing and looking at on our graphs. But we're just going to be looking at some key features. So the domain, the range, the vertex, axis of symmetry, x-intercept, and y-intercept. So remember our domain is our x's from left to right. And here is a hint. On our absolute value, our domain is always negative infinity to positive infinity. Ranges, remember, is our y's from bottom to top. And this one's going to be different depending on where our graph is. The vertex is, remember, the point in the middle or where they meet. And we're writing this as a point, so x comma y. Axis of symmetry, remember it's the x value of your vertex. It's x equals whatever this value is. X-intercept, remember it's where it crosses our x-axis. Pretty straightforward, and we remember, so it is where x is something and y is 0. So then, of course, opposite y-intercept is where crosses y-axis. X is going to be 0 and y is going to be some number. So let's look at these graphs. What do we say domain was? Negative infinity to infinity. And we can see by our graph in our example, y equals the absolute value of x minus 2 plus 1. It goes on forever to the left and forever to the right. Domain is negative infinity, infinity. Range, bottom to top. Bottommost point here is 1. And look, I already messed up. If we are writing in interval notation, we are using our brackets and our parentheses. And that point right there is on that graph, so we are using a bracket. And topmost is infinity. Vertex, where is that point? Where is this point right here? It is at 2, 1. Axis of symmetry. What is our x value of our vertex? 2. X equals 2. That's our axis of symmetry. Is this a maximum or minimum? Remember, if it opens up, then it is a minimum. Where does it cross our x axis? Why is that not right on that? It doesn't. There is no x-intercept. Where does it cross our y-axis? Right here, where x is 0 and y is 3. Easy enough looking at the graph. Again, this is always the same. Let me... Range, bottom. Oh, look. This time we're opening down, so it's negative infinity. Topmost value is negative 1. Vertex, that is right here, at negative 3, negative 1. Our axis of symmetry is x value of vertex, so x equals negative 3. Since it opens down, we've got a maximum now. And finally, where does it cross our x-axis? This one, again, does not. What about that y-axis? 0, -4. Okay, that is a negative. When we are given the graph, it's pretty simple, but sometimes we're just going to be given the equation. How do we find those same attributes? Again, our domain, well, it's the same. Doesn't matter what it is. So this is our basic formula for our absolute values, okay? And remember, our A, H, and K is where numbers are going to be placed in, okay? So if A, whatever number is here, if it's a positive number, positive, then it's going to open up. And if it's a negative number, then it's going to open, oh my goodness, negative. Why did that do that like that? Negative. It's going to open down. And we'll look at what that means in just a second. Our H, we're going to use the opposite for the x value of our vertex. Opposite, what do I mean by opposite? We're going to change that sign. K is going to be our y value, just as it is for our vertex. So our vertex, I didn't write it here. Let's pretend I did. Vertex is going to be negative H, comma, K. And I'll explain that in just a second. Our range. Okay. If it opens up, then our range is going to be bracket K, comma, infinity. It opens down. It's going to be negative infinity, negative H, bracket. Our x-intercept is where y equals 0. So we're going to plug in 0 and we're going to solve for x. We can have none or more than 1. And our y-intercept is where x equals 0. So we're going to plug in 0 for x and we're going to solve for y. Okay, let's see what all this means down here. What did we say our domain was? Negative infinity to infinity. Our range. Okay, let's take a step back. Is this one opening up or down? Remember, this is how we tell. I used the wrong color. We use this number and its sign for if it is opening up or down. Since it is negative, remember this is really a -1. So then it is opening down. Okay, so that's going to affect our range. Let's go ahead, before we do our range, let's do our vertex. So our vertex is going to be the opposite of this for my x, and then this, just as it is, for the y. So if it's +3, it's going to be -3 for x. If it was -3 up in our equation, it would be +3. So we do the opposite sign there. And the y, we don't change anything. Since it's positive 2, it's coming down as a positive 2. Now, I can look at my range. And we said that our range, if it's opening down, then it's going to be negative infinity. And then we pull in this number, negative 3, bracket. Okay, so we're using that what am I trying to say? We're using this x value in 2 places, for our range and for our axis of symmetry. Remember, we just pull in the same number. If it's opening down, we've got a maximum. Now here's a tricky part. Our x-intercept, we are going to plug in 0 for y, and solve for x. So we got 0 equals negative absolute value of x plus 3 plus 2. All right, we first need to remember how to solve for absolute value. So let's get our absolute value by itself. Subtract this 2 from both sides. Subtract 2, negative absolute value, x plus 3. Remember that really outside here is a negative 1. So I need to divide out that negative 1, divide out negative 1. Negative 2 divided by negative 1 is, well, I'll pick it up right here, maybe. 1 equals the absolute value of x plus 3. Just remember, we need to do 2, 1 positive, and 1 negative, x plus 3. Okay, so if we solve this, we got negative 2. Oh, this is a 2, guys. Come on. Negative, oh man. Negative 2 equal sign. This is negative 2. No, that's positive 2. Come on. I am tired. Okay, so over here, x equals negative 1. Oh my goodness. And x equals negative 5. Like I said, we have 2 x-intercepts. So negative 1, negative 5, 0. Okay. I'm going to change colors because we're going to now solve for the y-intercept. So we want to find out what y is if x is 0. So this time we don't do 2. There's not going to be 2 y-intercepts. If we look back at our graphs, it's not possible. So I've got negative absolute value of 0 plus 3 plus 2. So we act like our absolute values are our parentheses, and let's do that what's inside first. So 0 plus 3 is y equals negative absolute value of 3 plus 2. Well, the absolute value of positive 3 is positive 3. That negative sign outside, remember, it's really a negative 1. So negative 1 times a positive 3 is negative 3 plus 2 equals y. Y equals negative 1. Negative 3 plus 2 is negative 1. So this is negative 1. That was a lot. So I'm going to run through this example 4 and let me know when you have questions, because you most likely will have questions. So what do we say our domain was? Negative infinity to infinity. Let's take a step back. Let's do our vertex first. I should have put that one first. Vertex. So this is our x and this is our y. But remember, we're taking the opposite. So if it's positive 4, this is going to be negative 4. This y, we're leaving exactly the same. Okay? Is this opening up or down? There is technically a positive 1 right here. So it is opening up. Now let's look at our domain. We said if they open up, it's going to be our k value of -1 to infinity. Axis of symmetry is x equals -4. And this time we're going to have a minimum because it's opening up. Remember, opening up, we're going to have a minimum. When we're opening down, we're going to have a maximum. I'm not going to go through all of the math, but if you have questions on how I got these numbers down here, then you need to ask me. Jump on Zoom, email me, ask me in class, wherever you are, ask me how I got these intercepts because you need to know you will be tested over it. And that is all we're going to do with absolute value graphs now. We'll do something a little bit different later on.